difference between? Is it visible to anyone?
Yes, sir.
Difference between analog and digital. See, analog. Okay, analog is continuous in nature. It's continuous in nature. It is discrete in nature. Discrete in nature. Means there is no continuous. Discrete in nature. Okay. Second thing is, okay, if you take example, this is one analog signal. This is one analog signal. Okay, in this analog signal, okay, for example, okay, this is some voltage, okay, voltage, AC voltage waveform I consider here. Okay, here peak voltage is something like 5 volts, and here minus 5 volts will be there. Okay, plus 5 volts, minus 5 volts. Okay, positive peak voltage is plus 5 volts, negative peak voltage is minus 5 volts, total peak voltage is 10 volts will be there. Total peak to peak voltage is 10 volts will be there. But if you consider from 0 to 5 positive peak, 0 to 5 volts, how many levels we can do? How many levels we can do? Okay, it's a depends on user. It's a depends on user. Maximum how many levels can do is infinity number of levels we can do. Infinity number of levels we can create. How I can create? For example, okay, 0 to 0.01, one level is there. Okay, from 0.01 to 0.02 one level, then 0.02 to 0.03. If this go on like this, okay, approximately from 0 to 1 itself, 0 to 1 volt itself, how many levels we can get? We can get 100 levels. We can get 100 levels. Okay, understanding or not? We can get 1000 levels, 1000 levels we can get. Then 0 to 5 volts we can get 5000 levels. It depends on user. It depends on user. But one thing is clear here. Okay, these are you don't want. Okay, you have to remember only one. Okay, one thing is clear. For practical application, this many number of levels is not at all suitable. Not at all suitable. Okay, that's why we are going to convert analog signal to digital signal. Okay, so here what I can write the second point now. In analog consists of infinity number of levels. Infinity number of levels. But digital consists of only 2 levels. Only 2 levels. Okay, the 2 levels are either low level or high level. Only 2 levels. Either low level or high level. Either low level or high level. Okay. And if you take the digital, okay, this here I will write the waveform. This is the analog signal example. Here for the digital, we have only 2 levels. This is high level, and this is low level. That's it. Okay, this is about the signal, analog signal and digital signal. Next thing is third one. Okay, here storaging the signal is difficult. Storage is difficult. Storage is difficult. Here, storage is easy. Storage is easy. Means analog information to store it is very difficult. Digital information to store, okay, it is very easy. It will, okay, you are going to study about the storage in the sense registers. You are going to registers. You are going to study. Okay, there. Okay, I will explain more about this one. Storage is easy. And next one is, okay, it is difficult to design. Difficult to design. If you want to design any analog, difficult to design. But digital systems, you can design, okay, easy to Easy to design. Easy to design. This is difficult to design. Analog systems, okay, are very difficult to design. Okay, first day I'm allowing. Okay, from tomorrow onwards I won't allow. Okay, when they will, if class already started, I won't allow. No? Today I'm going to allow. Okay, these are the main differences. No? Okay, main differences. Analog, okay, is continuous in nature. Digital is in discrete in nature. Here, how many levels are there? Infinity number of levels are there. Okay, here only two levels, low or high. And here storage is difficult. Here storage is easy. It means analog information to store is very difficult. Digital, okay, information to store is very easy. This analog system to design is very difficult. It is easy to design. Okay, this is about the analog and digital. But one thing more, analog signal, how we are going to convert into digital. Okay, this is very important. I will tell. I will tell briefly. Okay, this is okay. This is okay. How we have to convert analog to digital. This one you are going to study in the I hope so third year. Okay, but I will explain. If we have analog signal, if we have analog signal, this analog signal you have to apply to the sample and hold circuit. Sample and hold circuit. The sample and hold circuit, okay, is going to produce discrete time signal. Discrete time signal. This discrete time signal, if you apply to the circuit called analog to digital converter. Analog to digital converter. If apply to analog to digital converter, then here I am going to get the bits. B0, B1, B2, and some B minus 1. Okay, this is in the form of binary information. Okay, see here. Your sample. This is analog. Analog signal. First, we need to convert into discrete time signal. The sample and hold circuit. In the form of circuit, I said that sample and hold circuit. But okay, you are going to study. You have the subject. What is the subject? Okay, signal system is there. Signal system. Okay, there you are going to study how we can convert analog into discrete signal. We are going to use very important theorem is sampling theorem. Okay, sampling theorem. You are going to study. For that sampling theorem, Fs is greater than or equal to 2Fm. You have to satisfy. You check it. Means analog signal. First, we need to convert into discrete time signal. This discrete time signal, what is the difference now? What is the difference between analog signal and discrete time signal? See, this discrete time signal is a replica of analog signal. It's a replica of analog signal only. But it is not in continuous in nature. It is not in continuous nature. Same. Okay. This is the analog waveform. Okay. I will draw here. This is also same replica, but here we are having the samples. It is in the discrete time signal. How we can convert? It is the same replica of the analog signal only. But here it is a continuous nature, but it is not in continuous nature. And this one sample, this one you can call it as a, here lines are there, right? Here lines are there. This one you can call it as a samples. You can call it as a samples. Okay, these sample we are going to apply to the analog to digital converter circuits are there. You are going to study analog to digital circuits. Okay, you are going to study few circuits are there. Okay, very important circuit is what we can call the comparator type ADC. Comparator type ADC. This is a fastest conversion. You are going to study in the. You are going to study in the third year. Okay, and we have ramp type ADC. Okay, successive approximation, register type ADC, and the dual slope ADC. These all are the 4 circuits are there. Okay, by using that circuit, we can convert from analog to digital, And very important thing here, okay, digital can understand one more thing. Digital can understand. Okay, digital can understand always binary only. Analog can understand. Okay, there is a language, right? Okay, we are. Okay, for analog, which language it can understand in the sense? Decimal. Decimal. Okay, here, which language it is going to understand? Binary. Okay. Binary. Okay, for digital system, which language it can understand? Binary language. Please keep in mind. Now, our first topic today, is number system and codes. Here, different number systems are there. What are these one? Decimal, binary, octal, hexadecimal numbers are there. Okay, first we will see. Okay, after that, and their conversions. Okay, we'll start with the number systems. Okay, today first topic is number systems. Okay, this is very important. First of all, what is number? Okay, what is or define number? What is number? Number is nothing but consists of group of consists of group of symbols. Okay, next. Okay, symbol. Okay, symbol is nothing but digits or alphabets. Okay. First of all, okay, I will take the example. For example, 565. This is a number. 1010. This is also one number. Okay, or maybe 6, 5. This is also one number. Okay, or I can take it as a 596. This is also one number. Okay, these are the examples of number. But 565, I can write it as a, this number belongs to octal. This number belongs to binary. This number belongs to hexadecimal. This number belongs to decimal. Sir, how we said this also? Okay, how we said this number belongs to octal. This number belongs to binary. This number belongs to hexadecimal. This number belongs to decimal. How you said this one, sir? We have few rules. Okay, based on that rules, okay, I can easily identify that this is a octal, this is the binary, this is the hexadecimal, this is the decimal. What are the rules we are going to discuss now? Now, very important thing is here, very important point is number what it can do. Generally, number what it can give, what it can do, number results what it can do. It can give some magnitude. Okay, it can give some magnitude generally. Okay, why these numbers are we are going to study? At the end, I will tell. I'm going to tell you. Okay, with the practical example, I will tell you. Okay, now number means number consists of group of symbols. Symbol is nothing but digits or alphabets. See, now check it here. Here some symbols are there. How many symbols are there? 3 symbols are there. Okay, these 3 are in the group. That's why I can call it as a number. But here, these 3 symbols are which type of digits? Okay, here also check it. Here also group of digits are there, but in binary you can call it as a bits. That I will tell you later. Okay, here AB65 is there. Okay, this is also one number, group of some symbols. But here the symbol consists of alphabet and also here it consists of digits. Here 596. This is also group of digits are there. Okay, that's why it is called as a number. Now, very important point we are going to discuss here. Format of number. This is very, very important. Format of number. Format of number. Okay. Now, every number have the format. Every number have the format. That format I will tell you. First, listen carefully. Okay. This dot is there. This dot I can call it as a base point. What I can call it as a base point or radix point. Radix point. Okay, for this dot, okay, if we take left to side, okay, if we take left to side, we are having left to side, we are having integer part. Integer part. Right side, we are having fraction part. Right side, we are having fraction part. This is very, very important. Please keep in mind. Okay, this is a base point. This base point, or I can call it as a radix point. Okay, for this base point, left side we have the integer part. The right side we are having the fraction part. Fraction part. Please keep in mind. My voice is audible. Anyone can reply. My voice is audible. And here it is.
Yes, sir.
Okay. And
Yes,
what I can call it as my screen is clear, right? What I'm writing.
Yes, sir.
Yes, sir.
Okay, thank you. Okay, see here. This is integer part, this is a fraction part. Okay, now integer part side. Okay, integer part side, I'm going to write. Okay, here I'm going to write it as a. This is D means digit, D naught into B power 0. D1 into B power 1. D2 into B square. And so on. D infinity, sorry, D suffix infinity into D power infinity. Now, if you come at the fraction side, D minus 1 into B power minus 1, D minus 2 into B power minus 2, and so on, D minus infinity into B power minus 1. If you observe here, integer side, I have given suffix and power values. Suffix and power values here 0, 0, 1, 1, 2, 2, infinity, infinity. These all are positives. These all are positive. Fraction side, if you observe here, minus 1. Here power side minus 1. Here digit. Okay, here D minus 2, D power minus 2, D minus infinity, D power minus infinity. Fraction side all should be negative values. Integer side all should be, okay, all should be positive values. Okay. Now, what it mean by this D naught, D1, D2, D infinity? The D minus 1, D minus 2, D minus infinity, what it means? I will write it here. Here, D infinity, comma, D2, D1, D naught, D minus 1, D minus 2, and so on, D minus infinity. These all I can call it as a digits. What I can call it as a digits. These all I can call it as a digits. And here we are having B power 8, B square, B power 1, B naught, B power minus 1, sorry, B power minus 1, B power minus 2, and so on, B power minus infinity. These all I can call it as a weights. These are very, very important. These all I can call it as a weights. Okay. Now, and very, very important thing is these all. Okay. These all I can keep with the bracket and I can write with the B or R. Okay, definitely if it is a number, I have to close with the bracket. Okay, for the closing of the bracket, bottom side, okay, I have to write it as a B or R. What is mean by B or R? B is nothing but base, I can call it as a, what I can call it as a base. R means radix. R means radix. Okay, these both can do, okay, same. Okay, what it means? Name is different, but both are same only. B is base, R means radix. Okay, this is the format of number. This is the format of number. Please keep in mind. You should not forget this one. If you forget this basic, it is very, very difficult. Okay, it is very, very difficult to identify the which number is. Okay, this number is belongs to which number system. This is a format of number. This is a format of number. Okay. Next, I'm going to take one example. See here, I'm going to take one example. Okay, which you studied in third class or fourth class, I don't know. 569.158 base 10. Base 10. Now listen here. Base 10. I taken one example. Okay, I taken one example. And here I written it as a base is 10. This is a base or radix. Base or radix is 10. What it means? This number is belongs to. Okay, this number is belongs to. This number is belongs to decimal number system. Decimal number system. I will tell that one. Okay, there are famous 4 number systems are there. Okay, that I will tell you. One of the famous number system is decimal number system. And from childhood onwards, we are or else humans we are using decimal numbers only. Okay, decimal numbers only. I will tell you later. Now, this decimal number, if I keep in format, how it will come? Okay, and if you want to study this number, how we can study ma? Okay, how we can study 569.158 we will study. Okay, why I taken this example? Because we are the humans. Humans are familiar with the decimal numbers. Humans are familiar with the decimal numbers. That's why. Okay, I taken this example. Now, this 569.158, if I keep in the format, okay, how it will come? If I keep in the format, how it will come? See, first of all, you have to identify. First of all, you have to identify. Okay, this is which one, ma? This is which one? Base point. This is which one? Base point. And base point left to side, this is which part? Integer part. This is fraction part. This is fraction part. Is it correct or not? Okay, now I'm going to keep it here. Okay, here. First digit, D naught place. Here, if you observe here. Here, D naught place. D naught place. Okay, D naught place. What will be there? Okay, 9 is there. Okay, I'm going to write with the 9 into B power 0. Okay, now tell me that here I already said that. Okay, at ending of the bracket, bottom what I can write as a base or R. R will B means base, R means radix. Here, okay, that base can represent with the B. But here in this example, 10 is it means okay B plus okay I can use 10 or wherever R will be there. Okay, I can write as a 10. Okay, now 9 into 10 power 0. Next one 6 into 10 power 1. 5 into 10 square. This is about the integer side. And here 1 into 10 power minus 1. 5 into 10 power minus 2. 8 into 10 power minus 3. Okay, I can retain this decimal number using format of number. I retain. You understand? You understand or not? Okay. Now, if you observe here, why I said that is 569. Why I said? Because 9 is at the ones place. 10 power 0. What is the value? This 10 power 0 value is what? 9 into 1 is
9.
9 into 1 is 9. Okay, this is which place? Ones place. Here, 10 power 1. What is this value? 10. 6 is at the 10th place. You studied 10 square. It is 100. 5 is at the 100th place. 5 is at the 100th place. Then this is the 500. This is a 6 into 10th place. That's a 60. This is a 1's place. 9 into 1, 9. Okay. If we add these three, 50, 60 plus 9. Okay. What you are going to get here? 569 at integer side. Fraction side. You can come to the fraction side. Okay. 1 into 10 power minus 1. That I can write as a 1 by 10. Here 5 by 100. Here 8 by 1000. 1 by 10 is 0.1. This is 0.05. This is 0.08. If you add these also, how much you can get? Okay, this 0.1 into 0.1 plus 0.05. How much you can get? 0.15. And this is 0.08. Sorry, 0.008. Then here I can get it as a fraction of it 0.158. Then totally I can get as a 569.158, and it belongs to the decimal number system. It belongs to the decimal number system. You understand? First of all, you understand or not? Okay.
Yes, sir.
And you can ask. Okay. You can ask one doubt, sir. You can ask one, sir. Is it the format is only valid for decimal number? No, it is the format of this one. This is the format. This format of the number will be suitable for any number system. Will be suitable for any number system. Okay, any number systems are, how many number systems are there, sir? See, there is a binary number, okay, decimal number, and hexadecimal number, octal number. These four are the very famous number system. Then why this having? Why, sir? These four are the very famous, sir. Remaining number systems are there or not? Yes, we have. Third number system is there. Fourth number system is there. Fifth number is there. Sixth number system is there. Seventh number system is there. 11th number system is there. Ninth number system is there. So, but there are n number of number systems. But why these four are the famous? Because these four number systems having some applications. Some applications. Okay. Now we are going to study about the different number systems. Now I will tell different number systems. Okay, before that, I will talk about the base or radix. Base or radix. This is very, very important. Okay, base or radix. Base or radix. First point, base is always positive integer. Positive integer. See, base is always positive integer. Now, base where we can write now? Base where we can write. For every number at the end of the bracket, we will write bottom. This is 8. This is 2. This is 16. Or this is third number system. This is 2. Finally, already written, right? Okay, this is a 4. If you observe here, these all are the bases, 10, 8, 2, 16, 3, 4. If you observe, these are the positive values or negative values? All are positive values only. And these all are integers values only. Integer means what the meaning? There is a no, okay, there is a no fraction part. There is a no fraction part. For example, okay, I will write it here. If I write 10.5, this is not at all a number. This is not at all a number. 10.5 having the integer part and also fraction part. Okay, I'm speaking about the base only. Please keep in mind. Base is always positive integer. Okay, next, second point is whatever the digits inside the bracket should be less than the base. Okay, what it means? See here. If I take one example now, here I will take one example. Okay, previous example, what I take now? 569.158. 569.158. 158 listed. Now see here, the point is, okay, whatever the digit inside the bracket. Now, inside the bracket, there are 6 digits are there. How many digits are there? 569.158. Okay, 6 digits are there. Okay, should be less than the base. Okay, base is what's the value of 10. If you observe here, 5 is less than the 10 or not? Yes. 6 is okay, less than the 10. 9 is 158, less than the 10. Then this is valid number. Is this a valid number or not? Which one can decide? Not base can decide. Another example. This is one example. Second example, I can write as a same number, 569.158. I can write as a 9th number system. This belongs to the 9th number system. Okay, is it valid number or not valid number? Tell me, is it valid number or not valid number?
Valid.
Valid. How it is valid? Based on this, check it. Whatever the digit inside the bracket should be less than the 9. Now base is 9, right? Base is 9. Now we check it. 5 is less, 9 is less. 9 and 9 equal or less? it is equal. Definitely it is an invalid number. It is a invalid number. You understand or not understand? Okay, another example. Okay. Okay, this is 457.67. Okay, is it valid number or invalid number? Definitely this is
Valid
number.
number.
Or valid, because base is 8. Inside the bracket, whatever the digit, all should be less than the all should be less than the base, less than the 8 only. Now I will try another example. Now check it. Valid or invalid?
Invalid.
Valid.
Okay, check it and tell me. Valid or invalid?
Valid.
Already said invalid. Valid only, because why? Base is 2. Base is 2. Okay, then based on these, I can tell that the range of numbers should be, in any number system, the range of digits from 0 to b minus 1. And then the b content, okay, it should be less than the b, right? Less than the b. That's why 0 to b minus 1. Any number system I can take it as a, okay, this is very important. The range of digits from 0 to b minus 1. 0 to b minus 1. What is meant by b? B means base. Okay, first point, ma. Okay, base can represent with small b. Or radix at a small r. If they use radix, smaller. Okay, if you use radix, this is r. Okay, now the range of digits from 0 to b minus 1. Okay, now I will give one table. Check it here. I will give one table. Okay, this table is very important. Okay, now base, range, maximum digit. Okay, next one, name of the number system. And last one is applications. Now see, this is the table I'm going to give. Okay. Here, base I can represent with the small b. Ranges from where to where? Just now I said 0 to b minus 1. Then maximum digit is definitely b minus 1. Name of the number system. First, I am going to take it as a base is 10. Base is 10 means the range is from 0 to, okay, b is 10. 10 minus 1 is 0 to 9. And maximum digit is 9. Okay, 0 to 9, how I can write? 0, 1, 2, 3, and so on up to 9. Okay, name of the number system is decimal. Name of the number system is decimal number system. Applications are, who are using this one? Humans. We are going to use. Okay, next step. Base is 2. If b is equal to 2, then the range is 0 to b minus 1 means 2 minus 1 is 1. Means only 0 to 1. How many are there? Only 2 is 0, 1. And maximum digit is 1. Okay, name of the number system is binary number system. And where it is going to be applied in digital or computers. Computers can understand binary language only. Okay. Now 8. Okay. Then range is 0 to 7. Then the 0, 1, 2, and so on up to 7. Here maximum digit is 7. And this number of the number system is octal number system. And where we can use, okay, old microprocessor. In olden days, microprocessors kids can understand octal. Okay, old microprocessor kids. Okay, next one is 16. 0 to 15. This is very important. Listen, 0 to 15. Now, if you observe here, 0 to 15 is it, then I can write the 0, 1, 2, 3, and so on up to 9. It is okay. After that, we have 10, 11, 12, 13, 14, and 15. Is it correct or not? Now, here one problem will come because, okay, here 10 is it. 10. Okay, if you observe here 10, then the system cannot understand this is a 10 or 10. It's a combination of okay, 2 digits are 1 is different number, 0 is different number. That's why okay, from here onwards, okay, for sorry, in the hexadecimal 10 means okay, I will write it in the next point. Okay, I will write it in the next slide. 10 in the sense in hexadecimal, okay, 10 means A. Okay, from here onwards I can use the A. 11 means B. 12 means C. 13 means D. 14 means E. 15 means F. 15 means F. Okay, now system cannot get confused. A means what it means? The value is 10, but the representation is A. Okay, B value is 11, but the representation is B. Okay, like that. For 15, you can represent with F. Okay, now the maximum digit is here I can write as a F. Okay, the name of the number system is hexadecimal. And what are the application present days in microprocessor? All kits we are going to use. Okay, this hexadecimal. Now the question is, sir, why it is called as a decimal? Why it is called as a binary? Why it is called as a octal? Why it is called as hexadecimal? Anyone can tell? Why it is called as a decimal? Anyone can tell? I can ask any one of the students. We'll see if they are listening or not. Harshavardhan Reddy 437, tell me. Harshavardhan Reddy. Okay, he is not listening to the class, then I can conclude. Manju Reddy. Okay, Pamadi. My voice is audible?
Yes, sir.
Jagadishwar Reddy, 444. Okay, Ravi Teja, 4A6. Okay, see. These students are okay, not at all listening. Okay, I can understand here easily. Okay, Kavya. Okay, Deekshita, Kavya, Anupriya, Anusha.
Yes,
Okay,
sir.
why it is called as a decimal here?
So I'm thinking so that on the
Okay, think.
the numbers which are in the base on them, I think.
Okay, that is okay. But exact reason is okay. 50% answer is correct. If you observe here, range you can observe. You count the range. How many digits are there? Range, count it 0. You have to start 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total number of digits are how many more? 10. Is it correct or not?
Yes, sir.
That's why it is called decade means what? Decade means 10. Is it correct or not? That's why they given the name is decimal. Binary, in the name itself, binary. Binary means there are two values. There is 0, 1. Octal means there are 8 digits will be there, but the range is from 0 to 7. Hexadecimal. See, decimal is 10, hexa means 6. 6 plus 10, 16. Okay, 16 digits are there. That's why they given the name is hexadecimal. Hexadecimal is 16. It will start from 0, 1, 2, 3, okay, up to 9. After that, A, B, C, D, E, F. Understanding on that? Okay, hexadecimal means there is a 60 digits are there. Octal means 8 digits are there. Binary means 2 digits are there. That we can call it as a bits. I will tell you later. And decimal in the sense 0 to 9. 0 to 9 means totally 10 digits are there. That's why they given the name. Okay. Okay, somebody. I didn't ask attendance, Mahi. Okay, Jagadish Reddy, I didn't ask attendance here. I asked a question. Okay, you are telling the attendance. then what's going to be happen? Check it. Okay. Now, how many students are, okay, I need one thing. Okay, open your video and tell me, okay, how many students are listening? How many students are writing first? How many students are writing? Noting the points are, okay. How many students are doing? Yeah, Manasa 461. Okay, next. Very good. Harsha 456. Don't share anything. Don't share anything, please. Don't share anything. Okay, Aditya, Ishwar Aditya. Okay, Pavi. Then Pavi, why didn't ask? Why didn't give the answer? I'm writing, sir. Monica. I called Pavni, right? Pavni. I called her name. Okay, that's it. 4 or 5 students only. Remaining students? See, this is the way you are doing it. Okay. Yeah, you are writing Dilan, but you have to you open and show to me. Amulaya 498.
Writing, sir.
Camera is shifting just wait, sir.
You don't want to give any answer. You show me. That's it. You don't want to give me the answer. You show me. I'm asking. Show me. I get. Okay. Very good. Very good. Very good. Okay. Very good. Okay. Okay. Few students only. Very few students they are writing. Okay. Okay. Remaining students they came for attendance. I know. Okay. Okay. Leave it now. Is it visible now? Is it visible? Check it. No, my slides are visible. Fast.
No, sir.
No. Yeah. Somebody shared. That's right. Okay. I will again. I can do the sharing. Somebody in between they share. Okay. I will present again. Now.
Visible,
Yes,
sir.
sir.
Okay. Now see here. Now we can ask now. Sir, 4 systems only, decimal number system, binary, octal, hexadecimal, you written 4, sir. Okay, why can't I take, okay, 4th number system or 5th number system? Yes, you can take it, but there is no application. For example, I'm going to write, same table, I'm continuing here, same table, I'm continuing here. First one is which one now? Okay. Or else I will copy this. Okay, I will copy this. Yeah. You can ask, sir, why you written these are. Okay. See here. Sir, you can ask a question. Okay, now, if I consider base is 4, okay, then the range will be 0 to 3. Okay, B is 4 means B means 0 to 3. The maximum digit is 3. What is the name of the number system? I can give it as a 4th number system because base is 4, right? That's why. And how many digits are we using? 4 digits are using. That's a 4th number system. 4th number system. Applications we don't have. Applications we don't have. Okay, understand? Like that, you can write. Okay, like that, you can write here. Okay, example, 9th number system also. Then base is 9 in the sense the range of is 0 to 8. What is the maximum is 8? What is the name of the number system? 9th number system. Applications we don't have. Understand or not understand? Like this, we have n number of number systems, but very famous number systems are only 4 are there. Very famous number systems are only 4 are there. What are that one? I already given in the list. Decimal, binary, okay, octal, hexadecimal. Understand? Now we are going for conversions. Now we are going for conversions. We are going for conversions. Okay, or else I will take few examples. You tell me which is a valid number or not. Examples. Okay, valid number or not valid number. First one I will write. Okay, first one means 912.56. 0.556. Wasted. It's a valid number or not? Tell me. 9112.56.
Valid, sir.
Valid, sir.
Valid,
That's
sir.
very good. It's a valid number or not valid number?
Invalid, sir.
Invalid.
Invalid.
Okay, very good. Invalid. It is a valid. Okay.
Invalid, sir.
Okay, very good.
Valid.
This is,
Invalid.
Invalid, sir.
valid or invalid? Why
Invalid.
it is invalid? Anyone can tell?
In
Base
base,
is
no
Base
decimals,
must
sir.
be
No.
positive, sir.
base is integer. It having fraction part. Okay, understand or not?
Yes, sir.
Invalid number. Okay, very good. Same number I will write. Valid or invalid?
Invalid, sir.
Invalid.
Invalid.
Because why? Why it is invalid?
Negative number.
Base is always positive integer. Base is always positive integer. Understand or not? I hope so. Okay, from today, okay, means up to now what we discussed, listen carefully. Here what you have to remember. Okay, you have to remember that format of the number system. Okay, and one more thing. The format of number system, I will give example for, okay, I will take the example for, okay, one more example I will take, but I'm going to take 101.10. Now this 101.1001 I have to represent by using number format. Okay, number format everyone remember or not? Okay, number format everyone remember? This is the number format. Everyone remember or not? Okay, here, okay, I need to represent in this one. Okay, this number. How I am going to represent it? Okay, observe here. First you need to identify which one. No? First you need to identify what is this one. Base point and the base point. Okay, this is integer part, this is fraction part. Understanding or not? This is a base point. Okay, this is integer part, this is a fraction part. Now I'm going to write this is a base point. Okay, here 1 is there. 1 into, okay, this is a, okay, 1 into, here base is which one? 2. Then I can write as a 2 power 0. 0 into 2 power 1. 1 into 2 square. Here, this is integer part is over. Here, 1, 0, 0, 1 is it. This 1 into 2 power minus 1. This 0 into 2 power minus 2. This 0 into 2 power minus 3. This 1 into 2 power minus 2. Do you understand? Okay, next example. I'm going to write, okay, 756.152 base rate. 756.152 base rate. This one I have to represent. Okay, I have to represent by using number format. See here, this is integer part, this is fraction part, this is base point. Okay, then I will start with the, okay, base point is here, then 6 is there. Okay, first note down 6, 5, 7. Then what is the base point? 8. Okay, this is a 8 power 0. 8 power 1, 8 square, and this is, okay, 1 into 8 power minus 1, sorry, okay, 5 into 8 power minus 2, and 2 into 8 power minus 2. You understand? You understand or not understand? The number, if they given in the octal, I can represent with the format. This is a binary number, okay, they given, okay. I can represent in the format number. You understand or not understand? Any doubts are there? Okay. Any doubts are there?
No, sir.
My voice is audible. Yeah. Any doubts are there? I can represent. Okay, I can represent like this. Like this hexadecimal also you can represent. Here, I'm going to give now very important point. Okay, what is it? Listen carefully. I'm going to represent here MSD. Here I'm going to represent LSD. Okay, this is very important. Throughout the subject, MSD, LSD. Okay, what is meant by MSD, LSD? I will tell you. Okay, I will take one slide, extra slide here. I will bring here one extra slide. Ah. Okay, MSD, LSD. Okay, first I will explain MSD, LSD. See here, MSD. If we expand the most significant digit, sometimes it is called as a MSB also. Most significant digit. What it means? Okay, which digit consists of which digit consists of highest weight? Highest weight. Which digit consists of highest weight? Called MSD, most significant digit. Next one is LSD. L means least. S means significant. Significant digit. Okay, same. Which digit consists of least weight? Called LSD. Called LSD. Now, what it means? See here. Once again, you observe. Okay, definition. Which digit consists of highest weight? Which digit consists of highest weight? Please keep in mind. Highest weight. That digit called as a MSD. Which digit have the least weight? That we can call it as a least. Highest in the sense what it means. Highest other name what I can write as a maximum weight. I can write it or not. Maximum weight. Okay, least means minimum weight. Minimum weight. Now take the example. Okay, in this one, B power. Okay, D infinity. What I said, but D infinity is a digit. D infinity, D2, D1, D0, D minus 1. These are all digits. Weights are which one? B power infinity. This is weights are B power infinity. Now, if you observe here, okay, from B infinity to B minus infinity, which one have the highest weight? Which one have the highest weight? B power infinity is the highest weight. That consists of digit is D infinity. That's why it is called as a MSD. D infinity is MSD. Here, B minus infinity having the B power minus infinity. B power minus infinity is the least weight. If you that's why it is called as a D minus infinity called as LSD. If you not understand that, okay, I will show here. Okay, now in this one. Okay, now in this one, tell me. 101.1001 is there. In that one, which one is LSB? Which one is here we can call it as a bits. That's why it is called as a MSB, most significant bit, least significant bit. Okay. Now tell me which one has the highest weight? If you observe here. Okay, black color will take. Here weights are 2 square, 2 power 1, 2 power 0, 2 power minus 1, 2 power minus 2, 2 power minus 3, 2 power minus 4. This is the highest weight. This is the least
2 squares, sir.
Yeah, 2 square. Okay, 2 power minus 2 is it?
2 power minus 4.
Yeah, you are saying that. Okay. This is the highest weight. This is the least weight. Respective of this digit means this will become MSB. This one will become LSB. Same here. You tell me in this example, in octet, you tell me in this example, which one is MSD? Which one is MSD? Which one is MSD? Which one is LSD? Tell me. Fast. Okay, you have the weights right. Tell me fast. 7 is
MSD.
8 square is MSD and 8 power minus 3 is LSD.
No, that is a weight. Weight respect to bit we had.
7 MSD, 2 LSD.
2
Yes, very
is
good.
LSD.
LSD. 7 is MSD. Please keep it. Everyone understand? And if you observe here, now onwards, okay, I will write weights on top now. Okay, I will write weights on top. Another example I will write. I will take another example. Okay, A, B, 5, 6, dot, C, D, F. Hexadecimal 16. Now I will write on top now. Here onwards I will write on top. This weight is 16 power 0. Can write it or not? This weight is 16 power 1. This weight is 16 square. This weight is 16 cube. Here it is 16 power minus 1. Can I write it or not? 16 power minus 2, 16 power minus 3. Now tell me which one is LSD, which one is MSD?
AMSD,
Which one is MSD?
A is
LSD.
MSD, FP is LSD.
Okay, very good. That's it. You understand or not? Understand? Is there any doubts? And very important thing, I forgot to tell here. Okay, here base. Okay, listen now. Base 10 will be there. Sometimes in problems they will give. Okay, D also. D, capital D. D means decimal. Or sometimes they will represent with the capital E. Means first letter, first letter. Or octal O. Or here hexadecimal H. You understand? Hexadecimal H. I can represent in this fashion also. And here you can talk here. What is the A value generally? What is the A value? What is the A value here?
16. 10.
A is there. A having some value, right? 10. Very good. A back to is 10. B is 11. Here C is there. C is 12. D is 13. F is 15. Understanding or not? Okay, please keep in mind. Okay, any doubts are there? First, tell me. Any doubts are there here? Okay, up to now, any doubts? Now we discuss. Okay, number systems. Okay, in the number system, see here. I will show to you. Yeah, number system. We discuss about decimal number system, binary, octal, and hexadecimal number systems. Is there any doubts? This topic is completed. Is there any doubts?
No, sir.
Okay, tell me, is there any doubts? If you have doubts, you ask me, because next we are moving to the conversions. Okay, if they ask, briefly explain about decimal number. Okay, decimal number system, what you will explain? Okay, I will tell you. Decimal number system, okay, the base is 10, first point. Next, the range of numbers should be 0 to 9. The total numbers are 10, we are going to use 0 to 9. That's why it is called as a decimal number system. And the format of the decimal number system. Okay, these points, if you write, that is about the decimal number system. Is it correct or not? Binary number system. Now, see, in the binary, we call it as a, okay, not digits, we can call it as a bits. Please keep in mind. We can call it as a bits. We call it as a bits. Okay, and you know that you studied in the any computer science, subject here. Okay, we can call it as a byte. Okay, 8 bits together, we can call it as a byte. You listen or not? One nibble, NIBBLE, nibble. 16 bits, you can call it as a nibble. You don't listen. Okay, whatever, we will leave it. Now, next topic we are going to discuss is, see here, their conversions. Now, we need conversions. Okay, decimal to binary, decimal to octal, decimal to hexadecimal. We need some conversion, binary to decimal, okay, octal to decimal, hexa to decimal. Okay, we are going to discuss now. Conversions. Okay, number system conversions. Number system conversions. Okay, there is a maximum chance to ask the 2 marks question. Here you can get maximum chances 2 marks question or 4 marks question. Okay, means sorry, 5 mark question, not 4 marks, 5 mark questions. Okay, now first one, see here one, I will give the common heading. Okay, first I will tell that decimal. Okay, conversion from decimal to any other number system, any other number system. This is important here onwards. Please keep in mind. Okay, before what we discussed, that all are the basics. Okay, from now onwards we are going to discuss the problem. This is very important. Listen carefully. First of all, decimal to any other number system, what it means? Okay, I can get subcategory here. Okay, first one is I can convert decimal to binary or not. Meaning decimal to binary or decimal to octal or decimal to hexadecimal. Or I can get as a, sometimes I can get the problem decimal to some fourth number system. Fourth number system also will be. Okay, for these all, I will give common procedure. Or for these all, I can get the, okay, etc. There are a lot of, okay, I can get etc. Okay. Okay, now these all, okay, can come under the decimal to any other number system. Okay, you don't want to remember decimal to binary, what are the formulas, okay, what are the steps, decimal to octal, what are the steps, decimal to hexadecimal, what are the steps, decimal to fourth number system, what are the steps. Individually, you don't want to remember. You remember decimal to any other number system. Given number is decimal, it has to convert where, either it is convert to binary or to octal or to hexadecimal or to fourth number system, or it is to seventh number system, whatever it may be. Okay, you have to remember. Okay, here the steps are, okay, now steps are, first step, steps. Okay, from where to where this is, proceed, where to where, decimal to any other number system, any other number system. Okay, before the step, okay, I will tell the, okay, before the step, okay, I will, okay, questions how they can ask, listen. They will give the number, here they will give the number, the given number is known value, tick means known value. Okay, this number, given number is belongs to which one, decimal. And here they will give required base, RB means required base. This also will give this question mark, means this, for this required base, we need to find the, this number. This number I can call it as a, okay, equivalent of the decimal number, equivalent of the decimal number. I will tell you. Here it is a question mark. This number. In the question mark, I need to find. This question mark, I need to find. Okay, RP means what is the minimum? Required base, where we need to convert. Required base. Okay, first you need to understand this format. My voice is audible.
Yes, sir.
You are also equal.
Okay, okay. Now, this is the format. Now, please keep in mind. This is the way of they ask the question. Now, first I will tell the steps, then we will do few of the problems. Steps. First step is, okay, and we know that for any number we have the integer part and fraction part. Is it correct or not? Integer part and fraction part. Now, here for the decimal we have, if the given number is decimal, right? Means for the decimal we have the integer part and also fraction part for the decimal. Okay, integer part of decimal, integer part of decimal, okay, integer part of decimal, or else, okay, I will do it. Integer part of decimal, what we have to do? Okay, perform LCM. Everyone know LCM, least. Anyone, what is my name? LCM, least. I don't know.
Least common multiple. Least common multiples.
Yes, least common multiple. Then perform LCM or successive multiplication method. Perform LCM or successive multiplication by using required base. Okay, this is the first step one. Second step, for integer part I said, for fraction part of decimal. Okay, now for fraction part, perform successive division. Okay, successive division by using required base. This is the steps. You have to remember this one. Okay, see here. Okay, first they are going to give the okay decimal number. if the decimal number consists of integer and fraction part, okay, if integer part is there, take that part, perform LCM or successive multiplication by using required base. Okay, here they will ask required base. We will see the examples. Okay, for the given decimal number, if it is a fraction part is there, perform successive division method or the successive division by using required base. This is the step. Please keep in mind. Now I will take one example. I will take one example. Okay. Now, $56.125 base 10. Okay. This is the question. So they will ask the questions are like this one. This question. Okay, I will tell you. Okay, one type of they asking the question in exam point of view. 56.125 base 10. Okay, is equal to. Okay, question mark they given and we need to convert where more. Where we need to convert. This is 2. Okay, where we need to convert in the form of binary. Okay, the given is decimal. Given is decimal. Given is decimal. Okay, from where we need to convert required base. Required base is 2, or else where we need to convert. Convert is binary. Okay, then decimal in the sense base is 2, binary in the sense 2. Binary is 2. Yes, given is decimal. Okay, decimal to binary we need to convert. First, in the question, in the decimal, they given integer part, fraction part. Okay, we'll check it, are both they given. Sometimes they will give only integer part. Sometimes they will give only fraction part. Sometimes they will give both integer and fraction part. Okay, now if you observe here, okay, this is integer part, this is fraction part. Understand or not? Now, first one. Okay, step 1. What is that one? Integer part of decimal. Yes. Okay, this is a 56. Is the integer part of decimal. What we have to do? We have to do. Okay, perform LCM or successive multiplication by using required base. Now, okay, 56. I'm going to take. This is integer part. Integer part. And here it is fraction part. Fraction part we have to take which one? 0.125. 0.125. Now, integer part what we have to do? We have to do successive. Okay, or successive multiplication or LCM. I will prefer LCM. Okay, this LCM with whom we need to do more? With required base. This is required base, RB, required base. Okay, 2. Okay, first I will complete this one. 2 2s are 4, 2 8s are. Remainder is 0. Okay, 2 1s are, 2 4s are. Remainder is 0. 2 7s are. Okay, 2 3s are. Remainder is 1. 2 3s are 6. Okay, 7 minus 6 is 1. 2 1s are. Okay, where I have to stop here? This this LCM where I have to stop. See here. Here we got it as a 1 right here. Okay, if we do with the LCM, okay, if we do with the LCM, is it possible? It is not possible, right? Sometimes we will make it as a 0 here. Okay, but what I am going to tell is, okay, here if this is a binary, sorry, this is a 2, then we got as a 1. When you will get here less than the base, less than this 2, less than the base, less than the required base, you stop it here. You stop it here. Okay, this is the way I can do the LCM. Okay, this is the way I'm going to do the LCM. Now this is 0.125 fraction part is there. This fraction part what we have to do? Perform successive division. Perform successive division. Successive division in the sense. Sorry. Wait. Sorry. Here I did one blunder mistake. Sorry. Okay. I'm sorry. This is successive. Sorry. LCM in the sense division, right? Here successive division. Sorry. Okay. Here successive division. LCM or successive division. For fraction part, successive multiplication. Sorry. Successive multiplication. Sorry, I will read it very blunder mistake. Sorry. Okay, perform successive multiplication for a fraction part by using required base. Now 0.125 is what? Okay, for 0.125 into 2. Okay, 0.125 into 2. How much you can get now? 125 into 2. How much you can get?
0.25, sir.
0.25? Is it correct? 125 into 2. Yeah, 0.25.
2.25.
2.25, not 1, 0.25. Now observe here, ma. Okay, here. Okay, fraction part you leave it, 25 we got. But here what will be there that you can collect here. Okay, 0. Now again, this 0.25 into 2 you can do it. Okay, 0.25 into 2. What we can get, ma? 0.5. This 0 you can collect 2 here. Okay, next 0.5, this one, 0.5 into 2. Then we can get 1.0. Then what we got now? 1 is there, then take it as a 1. Take it 1. Okay. Okay, after that, you have to consider as a 0.0 mark. 0.0 into 2. 0.0 into, okay, 0.0 into 2 is what the value? 0.0 only. It doesn't change. If how much else you can do the multiplication, it becomes 0.0. Okay, understand or not understand? Or else I will do one thing more. Or else I will tell in another way. If you have confusion here, I will tell in another way. I will tell in another way. Okay, take fraction part 0.25 into 2. Okay, if you multiply this one, how much you can get? 0.25. Before this, 0 will be there. Don't forget. But for you to listen, 0.25 into 2, definitely you will get that 0. Okay, 0.25. Okay, this 0 take out. This 0 take out. Write it 0.25 only. Write it 0.25. 0.25 into 2, 0.50. Okay. Then this 0 take out and write 0.5 only. 0.5 into 2, it is 1.0. Take it out 1, then write as a 0.0 into 2. Then what will you get, ma? 0 point into 0. This is 0. Means, okay, no need to do the multiplication next. Is it correct? And a 0.2 into 2, same value only. Same value only we have to get. Or when you will get the here 0.0, okay, 0.0, stop it here. 0.0, stop it here. Understanding? Stop it here. Okay, before itself here. Where we get 0.0, stop it here. Now, if you observe here, okay, I did the integer part successive division method and fraction part successive multiplication method I did. Now, here I need to collect the remainders. Here, remainders how we need to collect. I need to collect in sense. Here, the remainders I need to collect from the top to bottom. Sorry, bottom to top. Bottom to top. I need to collect bottom to top. And here I need to collect from the top to bottom. Top to bottom. Then I can write integer side I can write. Okay, from bottom to top, please keep in mind here 1, 1, 1. 3 ones are there. 0, 0, 0. 0, 0, 0. This is a fraction part of binary. Fraction part. And here it is 0, 0, 1. 0, 0, 1. This is a sorry. This is integer part. Sorry. This is integer part. Sorry. This is integer part of the binary. This is a fraction part. In between these two, I need base part. Now you can check it. Is it valid binary or not? Check it. Is it valid binary or not?
Valid, sir.
Is it valid? Valid or not? Yes, it is false. Definitely it will come okay, valid binary. Because it consists of only ones and zeros. It consists of only ones and zeros. This is the way we are going to convert okay, decimal to binary. Okay, that's why I given generalized is what I given decimal to any other number system. Okay, they will give the decimal number. For that one, integer part is there. Take that integer part, perform LCM. Okay, and fraction part is there for decimal. Take that one, you can perform the successive multiplication method. But here one important thing is where I can stop the integer. Okay, LCM. Okay, here we will get the here we will get the 1 point we will get the okay less than of the base we will get here. There you can stop. Here 1 came, here 2 came, less than of this. Okay, you have to stop it. And fraction part, this multiplication, okay, where we have to stop? 0.0 will get 0.0. Okay, there you have to stop fraction part. Okay, this is the way we are going to convert. This is the way we are going to convert. Understand or not understand? Okay, we will take another problem. We will take one more problem. Yeah, it's almost 4, okay, but no problem. I'll take 5 to 10 minutes extra. Okay, I will take one, exact values. Exam. Wait a second. I have to take some exact value. If I take it is good. That's why I'm trying. Okay, I will take simple value. Simple value. Yeah. Okay, next problem is 175.25 base 10 to convert it. Look at this. 175.25 base 10. Okay, need to convert. Okay, the conversion is where to where from? Tell me first, the conversion is from where to where? Conversion is from where to where? Hello?
Decimal to binary.
Decimal to octal, sir.
Binary now.
Decimal to
Binary.
octal.
Before who speak, okay, tell me who speak. So you give an answer.
Decimal to octal.
Number binary, how it is binary? Decimal to octal. Okay, now here integer part is there. Condition. Here integer part is there. Yes. Here fraction part is there. I will do one thing. Give me answers. Okay. Same procedure. You try to give me answers. Same thing only. Same procedure, but before we have binary, here we have octal. Okay, you can type it. 217.4. Okay, you will see. Okay, 217.4. Two students they give an answer, we will check it. Okay, see here. Okay, first one is integer part, fraction part. Integer part is 175, fraction part is 0.25. Take it as a 0.25. 0.25. That is solution. Okay, here I have to do LCM. With which one? Required base is 8. Here, multiplication. Required base is 8. Okay, 8 2s are 16. 1 is remainder, 1 5. Okay, 8 ones are 8. Okay, then 7 is remainder. 8 2s are 16. 5. Oh, sorry, 16. Yeah, 5. Okay. Okay, here we got as a less than of 8, right? Less than of 8. Okay, 2 it is less than of 8, then I have to stop. Okay, 0.25 into 8. 0.25 into 8 is 4, right? 4.0. Okay, take 4 and here. When we get the 0.0, we have to stop it here. Here, we need to collect from bottom to top. Here only 1 2 is it. Okay, then 257.4 is 8. Is it correct or not? Check it.
No,
217.
sir.
Yes, sir.
255, 257.4.
Mine is correct. They given 217. Which one is correct?
257.4 basic is correct, sir.
Yeah, this is correct. Yeah, this is correct. Okay. Understand? Okay, I will give few of the example problems you try at home. Okay. Home. Okay, tomorrow, next class, I need. Okay. Now I'm going to give. Yeah. Okay. These are examples. Okay.
Sir, second one, sir.
0.375 base 10.
0.37.
Only fraction
Okay.
part I give. Another example. 5. I will give round of 5. Okay, ma'am. These are the 5 examples. Okay, tomorrow, next class, you have to complete these problems and solve. Okay, tell me any doubts are there regarding this? Any doubts? If you have doubts, ask. Today class, if you have any doubts, ask me.
Sir, analog to digital conversion.
Okay. I'm not to this information.
Second step what, sir? After comparator type ADC and
That all you don't want now. That will get in third year. Okay, not issue. You will study again. Okay. There are 4 types of circuits are there that we can call as analog to digital converter. First one is what I repeat, the comparator type, ramp type or counter type ADC. That numbers that circuits you don't know. Why you are much eager of with this? That is out of notice. Anyway, you should not be concerned. Comparator, ramp type, such a approximation. RAM type also called as a counter type. Comparator type you can call it as a flash type. Okay, there are other names also. Okay, this is the this type of teaching okay or to directly represent with the slides. See this subject to okay if I given slideshow already made slides, you can't understand the subject. Okay, this is okay. Is there any difficulties you are facing here? Is there any difficulties?
no, sir.
This is okay for you.
Yes, sir.
Okay. These slides, what I can do is after completion of one topic, after completion of topic, I will do one thing. I will upload in the Google Classroom. I will create the Google Classroom. You can access this one. And one more thing is, okay, I said right, I recording. Okay, I'm recording the session also. If you want, I will share it with you. Okay.